Item B, intrinsic geometry, exterior algebra in 3D or ND, okay? The nth dimensional space. Okay? Now, B part 1, manifolds. B part 1, lecture 12, the cotangent space on a curved manifold. Now, I will start over here. You see, I already did this, showed this, so I'm repeating. Recall that the differential of a function, phi, is partial phi respect to xi, dic xi. I here is a dummy index. Now let phi is equal xj, this coordinates here, okay? So this contravariant coordinate, okay, because j in the upper index. So the differential, just substitute here, you see, you just replace phi by xj, okay? And partial xj respect to xi, attention, the coordinates, they are independent. So this will be 1 if j is equal to I. This will be 0 if j is different from I. That's why the derivative of xj respect to xi is delta ij, by definition of delta ij, the conic delta. 1 I is equal to j, 0 I different from j. Thus, dxj is identical to dxj. Hence, attention now, tensor is a map by definition. You see, this vector acts on this one and leads to a scalar by definition of tensor. So this is an introduction just to go to lecture 12, the cotangent space. Recall that the curved manifold is Euclidean. On a smooth manifold M, the cotangent space at a point P, denoted by T asterisk Pm, is the dual space vector. Don't forget that. See? So there's a dual space, okay, of the tangent space, the dual, okay? Like here, you see? You see, this dual space, okay, is related to this one. You see, because this acts on this one and leads to a scalar quantity. That's a definition of a tensor. That's why this here, TPM asterisk M, is a dual, okay, of DPM. Now, this is a tangent space, you see. This is a dual tangent space. Here leaves the xi, and this leaves partial of xi. You see, that's important here. This is a dual space. Now, for local coordinates, you see, that's assuming the n is the dimension, okay? If it's 3, use x1, x2, x3. This is 4, x1, x2, x3, x4. Though this in general for m dimension. On M, the manifold, the standard basis for the vector space is this one, okay? This is a partial derivative, okay? Like as here, okay? This is a space vector, and these are the dual space vector, or called covector. You see, covector space, okay? dxj in general is called as one form. The scalar is 0 form on the exterior algebra, okay? You have a 2 form, 3 form, and so on. So a vector is a vector, is a 1 form. Now, continue here. The corresponding dual basis in this TP asterisk M consists, you see, this, attention now, these vectors, okay, dual vectors, they span this space over here. You see, this is a dual vector. Okay, this is a dual vector. Okay, this is a vector, vector. This R, the dual vector. So let's continue here. The basis, the dual basis, satisfy the duality relation just over there. You see, the xi partial that xj is delta ij. Just is written over there, the chronic delta. This structure ensures that this dual, in this case, the dual space, dual vector space, is an nth dimensional real vector over R. You see? Why over R? Because each point of the curved surface can be represented as Euclidean coordinates, as I mentioned there. And points in the tangent space, they are the approximation of points on the manifold. That's why I always insist on call the attention, call this important observation that's using, you see, the Euclidean, okay? Just the point on the manifold is labeled, okay? Is labeled, okay? They are coordinates. These coordinates are Euclidean coordinates. If you use the tangent vector or the cotangent space vector, you see the points over here, they are the points which was approximated from the manifold. See, that's a important emphasis, which I always insist in doing that. So those are, this case, you see the dual vector space, you see that's the basis, that dx y. It's a one form in this case. We could have a two form, see? Then I have here, do you remember, V, a tensor product order V, and this V star tensor product order V star. So it will be a dual vector space. Exactly what we did on the Eaton A, okay? Just review part 1 till part 7. You go over there and see it, you study it, okay? So this is a cotangent space on the curved manifold.